Okay, cool. Okay, perfect. Yeah, great. So thanks for having me along. My name's Alastair. I'm a postdoctoral researcher here in the University of Edinburgh in the Grant Institute. So I'm going to talk a little bit about this project, which I was involved in a while ago in terms of setting it up. And we just got around to having the cruise, which was in Chile. It was on this ship here called the Falkor 2. So this ship is owned by the ex-CEO of Google. So it was a really high-tech ship. I'm just going to actually start just to introduce the project. I'm going to start with a video for us to watch because we also had like a videographer on board who made all these amazing videos. So it's a shame to kind of put those to, not put that to good use basically. But there's a lot of people involved in this, all these different logos, all these different people. It's a massive international project. And without further ado, I'll move on to the video. Hopefully it plays. So, yeah, brilliant. Thanks.
Effects of volcanism on the marine environment. We're interested as a science team in exploring the impacts of volcanic events when they interact with and influence the marine realm, and that's primarily through the sediments that are flushed through river systems into the adjacent sea. Now, Southern Chile is a landscape shaped by glaciation and by volcanism, and one of the big science questions that we're interested in is the relationship between glaciation, ice cover on the Earth's crust in this part of the world, and how that might have interacted with and influenced volcanic behavior, the frequency of volcanic eruptions, the size of volcanic eruptions, the style of volcanic eruptions, and the hazards that they pose. Para la gente que vivía alrededor, muchos de ellos no sabían, la mayoría de ellos no sabían que era un volcán. Primero actividad en una forma de temblores, después se ve la columna eruptiva, que fue bastante significativa, y luego empieza la ceniza a subir la atmósfera, se empieza a trasladar por los vientos hacia el este, hacia Argentina, el Océano Atlántico, y en algún momento este río que se llama el Río Blanco, que pasa por la ladera del volcán, y que antes iba vecino a Chaitén, traslada todos estos materiales volcánicos, decide cortar la ciudad en dos, todos se inundan y la gente se enoja y están tratando de reconstruir, ¿verdad? Ahora con una ciudad que tiene una forma distinta porque está cortada en dos. So this event transformed the local geographical landscape of the Chaitén region, and major impacts on the human population of the town. The town has been rebuilt, but the imprint of that eruption remains, and it's the sort of major events that have affected this region.
What I'm most excited about is not just understanding what's there today, but looking in the past. So on this particular cruise, we have the capability with the RV and with something called a gravity core, which we can actually take sediment cores from the sea floor with these little tubes of sediment, these little straws, and we can actually look at layers and see where we have volcanic deposits and really understand how volcanism interplayed with the marine environments that we're in today and past.
One thing I'm really excited about in this expedition is the breadth of science that we're undertaking. This is truly cross-disciplinary. We're bringing together marine biologists, oceanographers, marine geologists, volcanologists. A lot of the people on this expedition are new to this type of science, so we're also sharing knowledge and training the next generation of scientists. The methods that we're using are novel. We'll be collecting some of the first cores from this area, and certainly the first ROV-based cores, so we can actually see what we're collecting on the seabed and get a perspective on these volcanic events that are simply not been possible previously.
Okay. Yeah, so I just thought that was a really good way of, how do I come off this? There we go. Not again. Yeah, so I thought it was a really good way of just introducing the project. So the project is a really interdisciplinary project. It's primarily around volcanology, around volcanism. The main point of this cruise is to look at the effects of a volcanic eruption on the marine environment. So where and why? So Chaitén volcano in Chile erupted in 2008, as it mentioned in the video. It erupted without any prior warning, and they managed to evacuate 4,000 people from the town. They got everybody out. Everybody survived in the primary evacuation. So it's held as a success story. It was one of the first rhyolitic eruptions that we've seen in the past 100 years or so in sort of very modern times, really. And it produced this massive ash column, which went all the way across to Argentina and deposited ash all the way across Argentina. However, because we're right on the sea, we don't really have much of that recorded apart from through the lahars, which came right down and destroyed the town. And these lahars then entered into the ocean, and we don't really know anything about it from that point. So the point of this project was to essentially map up through these fjords and into the ocean, to look at recover these sediment cores and recover these sediments, and to understand the effects of this eruption on the marine environment. So looking at below that eruption, during that eruption, and after that eruption. This is just a map which shows all of our different sites. There's these little yellow dots. Our permit area was the kind of yellow line all around the outside. And we've got a real range of depths here. So the majority of depths that we were in was around about 200 meters water depth, but we did go to 3.5 kilometers depth as well to look at right onto the continental shelves and to look at the effects there as well. So just in terms of the different methods that we employed on this, so first of all, marine geophysics and mapping. So this image up in the top right, you can see has got this depiction of a ship, and this was multi-beam echo sounder data. So we're essentially sending these pings down and using this to map the surface, get the bathymetry of the ocean floor, and to look at these chirp profiles as well, where we could see these sub-bottom shallow submarine geophysics within that. Within these, we were then recording where we were going to target our sites for our ROV, which is our remotely operated vehicle. And we could build up a picture of what was happening as well within these areas. So this just shows 3 different images. It shows the final bathymetric map that we'd made. It shows the backscatter, and it also shows the MBES data, the marine, the multi-beam echo sounder data as well. And you see here, just automatically, we've got these dunes, these really large dunes, which first time we've come across these. We're still working on what these are, what processes have led to these, but it's likely some sort of glacial feature that's led to this. We also use the CTD for conductivity, temperature, and depth. So this is where we essentially have this giant cylinder full of water canisters, and these can fire at different depths, and we can record all of this information around about the salinity, the temperature, and any other properties about the water there as well. And this is our remotely operated vehicle. So this is called Sebastian. We sent this down. It's kind of about the size of a small car. And it's got loads of different types of highly sensitive equipment on it. It can measure the water as well. It's got this big tube on the outside of it that you can see that is just a big giant vacuum cleaner for sucking up biology off the sea floor. And you can see just on the other side as well, you've got just pointing out up here, you've got these little tips at the top, which these are our vibrocores at the edges. So this is what we're primarily using, these vibrocores to collect the sediments on the seafloor, as well as push cores as well to get the upper sediments. We had a massive control room for this, just some images of, I think there were about 45 screens just in this one room. It was all different things. It was always being live streamed on YouTube to around about 80 followers that religiously kind of sign in and look at this, and we had to do commentaries the whole time as well. So you can go back and watch these if you want to hear me trying to talk about sea slugs and things as a volcanologist. But yeah, that was a really kind of fun part of the cruise, and this kind of public engagement element of it as well. In terms of the biology, I'm not a biologist, so I don't know what half of these are. But we pulled up a lot of different things. These sea slugs, this really weird, had loads of little tentacle things on it, kind of all the way around. But thankfully, we had these 2 Chilean biologists who were absolutely fantastic, and we're looking out for new species the whole time, sieving through all these grab samples and these bags to kind of look at the modern day environment that we've got here. And I think this is potentially a new species, I think, if I remember correctly. Not sure exactly what it is, but yeah, it might be a new species, it might not. But the push cores, so these are just kind of collecting the upper sort of 30 centimeters or so. And these were, you can see nicely in this image here that you've got the ROV dive stream happening at the time. And that's these push cores here. So the robotic arm basically pushes them down as little tubes into the sediment, pulls them out. And then we've got Natalia here who's just cleaning it up, ready for us to work our way through. And this just shows an example of how we sample from these. This is taking sort of one centimeter sort of slices through this, basically taking them as little slices of cake and keeping them in a bag. And then you can record down in terms of this, and you can see us all discussing here various different samples. We also then collected some deeper cores as well, not from the ROV, so we collected gravity cores. These didn't work as well as we hoped, but this is essentially a big giant metal tube that we put a whole bunch of weights down. The idea is it dries down and collects more material, as well as some grab samples, which is like a big giant scoop, which essentially scoops up all the sort of upper 50 centimeters or so of merging. You collect that all and you can subsample from all of that as well. But the main point of this was these vibrocores that we'd collected. The vibrocores, it's kind of a method basically where you have these giant cylinders and you create vibrations to essentially push away the sediment on the outside, but keep the sediment on the inside of that core. This image here shows an ash layer, a volcanic ash layer. This is a mafic volcanic ash layer, so a silica pore eruption. Within that, we've got a very detailed log that comes through that, 1 tephra of various different grain sizes in this. And we're trying to match this up in terms of its source, look at the eruption dynamics. We can see it's very different from background sediments. And we put all these different flags in as well for all the different areas of the science for what we wanted to flag up and sample. And there's just an image of me here just kind of getting these little toothpicks in. And these toothpicks are kind of a really rapid way of doing science on board the ship. So if we come back to the lab here in the university, we can look at these under the microscope. We can do lots of fancy things with them. We can make thin sections, so we can do various different methods that we employ in these. But on a ship, you've got very limited capabilities. So these are making something called a smear slide, which is where you take a little bit of sediment, and then essentially you put these onto a slide, dry off the water, put a cap on them, and have a look at what you've got. So yeah, essentially this here is showing some of these microscope images from the ship. It's showing various different types of grains, but you can see here in section B on this one and on E and F on this one that these are quite different grains to all the sort of cruddy background sediment. These are volcanic lahars. So within this one, they're very clear, they're very clean. This is from a sort of rhyolitic eruption. These are very silica-rich. Whereas if we look down at F here, you can see it's quite brown. It's got a lot of vesicles kind of all stretched in. And this is from one of those more mafic eruptions like the one I showed, a darker ash deposit. This is something called palagonite, which is where the ash is actually altered a wee bit, and it's actually altering and having that brown appearance and that brown color. So I can talk absolutely loads about this cruise. So we had loads of outreach things that happened. We've got loads of different channels and things of what we're going to do on the next steps. But just before I kind of close off, there's one other video which kind of explains these vibrocores, which the reason I want to show this video is because it's this vibrocore was developed just for this cruise. So it's now being used by the shipping company going forward for lots of other things. And they've mainly done a lot of biological cruises in the past, but this is one of the first kind of real geological based cruises that they've sort of done. So I'll just leave you on this, which explains a little bit more about the science, a little bit more about the vibrocores. I'm happy to take any questions after.
So we are operating in the inland waters of Southern Chile at the moment. Super exciting cruise to be on. This is the first time the organization, the Falkor 2, has been in this area. So we're all excited to be here. We've got a few different pieces of equipment on board, one of which has been in development for the past 5 years. That is the vibrocore. A big component of this cruise is using the ship's mapping systems.
Mapear el urbanismo trascendental en este tipo de expediciones, debido a la cantidad de información que no tenemos todavía y que es necesario para poder identificar aquellos sitios que son de alta relevancia. Por lo tanto, tener mapas disponibles de áreas que todavía no han sido descubiertas es extraordinario. Yo me siento como un científico que está descubriendo el espacio, por ejemplo, ya que estamos explorando y mapeando áreas que nunca han sido mapeadas. Lo han hecho anteriormente, pero a muy baja resolución y en áreas reducidas. En cambio, hoy estamos realizando un mapeo de alto detalle.
Entonces, una vez que tenemos mapeado el fondo marino, lo que hacemos es bajar ese rock y luego recolectar los sedimentos que están en el fondo. Dentro de las cosas interesantes que estamos ocupando en esta expedición es en inglés Vibracore, que es un instrumento que se monta en el vehículo submarino, en el rock, y tiene la particularidad de que vibra. Entonces, los sedimentos, principalmente arenosos, tienden a liquefaccionarse cuando se tiene esta vibración. Ocupamos este instrumento para eso, para poder pasar estas capas arenosas y también para tener una mejor penetración en algunas capas que pueden ser de arcilla, de barro en general, arcillas o limos. Estamos buscando capas de tefra, que es básicamente material que sale de las erupciones volcánicas. Sin embargo, para tener una idea completa de qué es lo que vamos a obtener, hay que traer los testigos al laboratorio, abrirlos y ver qué es lo que hay dentro de ellos.
So once the course has been split, we bring them into the lab. This is the main lab where lots of scientists are busy working away, and we start to describe it all and look at what is happening within the section. So here automatically we can see that we have a very wet, muddy layer at the top. It has this light grey layer, which is here, which is a volcanic ash layer. And as we go further down, it becomes more sandy. So this volcanic ash layer, if an eruption happened several years ago, can inform us about the processes that happened there and will happen again in the future. And we can understand and plan for these hazards to try and protect people and save people's lives from these eruptions in the future.
Entender cómo se acomodan o cómo se agrupan los sedimentos en el fondo marino y su interacción o relación con la parte terrestre es fundamental, ya que son como piezas del puzzle que estamos lentamente descubriendo y uniendo. De esta forma podemos crear esta unidad o reconstruir esta unidad volcánica a través de los sedimentos marinos y explicar parte de la historia del pasado. La Tierra ha ido evolucionando y ha dejado una huella o su impronta en el fondo del mar.
So yeah, so I just thought that was a nice video to kind of sum up exactly, you know, what we were doing really, and the main kind of plan for the ship really. And yeah, so I think we basically recovered. Oh, sorry. There you go. Yeah, we recovered absolutely tons of samples from these. We've got loads of cores which we've got archived, and we're going to do lots of scans on. But yeah, really, there's lots of science which now is a big step for everybody to take away and build this up as a sort of collaborative effort basically now, and try and reveal the real secrets of this. So I'll leave that there and ask anybody for any questions. Thank you very much.